The problem states you wish to estimate a mean number of minutes that it takes to drive to work every morning. So you start to collect data every day during your commute, and you collect data for 50 days straight, and find that the mean number of minutes it takes you to drive to work is 23.14 minutes. You also believe that the population standard deviation for all of these days that you would ever drive is 3.21 minutes. Build a one sample Z interval to estimate the true mean number of minutes that it takes to drive to work with 90% confidence. So let's start by identifying all the key pieces of information that we have here. So the first thing is we did this and collected data for 50 days straight. So we have 50 pieces of data. That's our N. What else do we find is out of those 50, when we calculate our mean, we find that we have a sample mean of 23.14. So that's a sample mean X bar. And then also says that we believe that the standard deviation of the population is 3.21. So population standard deviation is sigma. And lastly, they want us to use a 90% confidence interval. So we have to figure out what is our Z star, our critical value that matches up with 90%. So this is one of the common ones that we can use, but let's take a look at how we would calculate this Z star. So since we want to be 90% confident, then that means our values need to capture 90% of the distribution. And so if we type this into StatCrunch, let's see what we get. So in StatCrunch, I'm going to go to Stat, Calculators, Normal. Again, we're trying to capture in between these two Z-scores, and so we're going to leave it at 0, 1. And to be 90% confident, I'll type in the 90% onto the right area. Compute, and we get 1.6449, or if we round it to 3 decimal places, the common number we often use is 1.645. So let's write that down, 1.645. So we have all of the pieces that we need to build this interval. So recall, what is the formula for building a confidence interval? It's going to be our point estimate plus or minus our margin of error. Well, our point estimate, if we're estimating a population mean, is just our sample mean. So let's just use this sample mean of 23.14 as our point estimate, because that's our X bar. And then our margin of error, remember, it's the number of standard errors away from the mean we want to go. Well, we already know that this is going to be a Z star, number of standard errors. And then how big is a standard error can be found by taking our population standard deviation divided by the square root of n. So we'll just plug all of our information into here. Our point estimate is 23.14. And we have our Z star of 1.645. And since the standard error is going to be the population standard deviation divided by the square root of n, we can put those two pieces of numbers in there. And let's see what we get. So I'll start off with first just calculating this margin of error right here and simplifying that. So if we calculate that, we get 0.747. So now we're at 23.14 as our point estimate, plus or minus our margin of error of 0.747. And finally, since we have the point estimate and margin of error, we can now calculate the actual lower and upper bound. So we'll just do the minus version and the plus version. So if we take 23.14 minus 0.747, we get 22.393. And then if we find the upper bound, 23.14 plus 0.747, we get 23.887. And there is our confidence interval. Our 90% confidence interval. We are 90% confident that the mean number of minutes that it takes to drive to work is between 22.393 and 23.887 minutes.